Today in geometry, we're going to look at section 6.3, which are similar polygons. So let's start out with vocabulary. What is a similar polygon? So similar polygons are polygons whose corresponding angles are congruent and corresponding side lengths are proportional. So here we have QRST and ABCD. So it tells me that the order of vertices in a similarity statement identifies the corresponding angles and sides. So this statement, QRST, is similar, so that is our symbol for similar, to ABCD. So my corresponding angles, okay? So again, the symbol for similar is that little one squiggly line. So my corresponding angles. So Q and A. So angle Q is congruent to angle A because they tell me corresponding angles are congruent. R and B. So angle R is congruent to angle B. Angle S congruent to angle T. Or, sorry, not angle T there. Angle S is congruent to angle C. And finally, angle T is congruent to angle D. So now we want the ratios of the corresponding sides. So they tell me that QR is proportional to AB. So we look up here, QR is marked 36 over AB is marked 24. The ratio now, we need to simplify if we can. So 36 and 24, the biggest number that they have in common is 12. So that reduces to 3 over 2. TS is marked 24. DC is marked 16. So again, I need to reduce that, 24 and 16. The biggest number they have in common is 8. So 24 divided by 8 is 3. 16 divided by 8 is 2. QT is marked 19.5 over AD, which is 13. Right here I have 19.5 and 13. I need to get rid of that decimal. Remember, if I just divide by the decimal, so divide by 0.5, whatever I do at the top, I have to do the bottom. So 19.5 divided by 0.5 gets me 39. Over 13 divided by 0.5 gets me 26. So now 39 and 26, the biggest number that they have in common is 13. So this reduces down to 3/2. The last one, RS, is proportional to BC. So RS is marked 18. BC is marked 12. The biggest number that 18 and 12 have in common is 6. So this reduces to 3 over 2. Notice I got the exact same ratio every single time. That will always work because the corresponding sides are proportional. So I will always get the exact same ratio on my corresponding sides. All right, so the next one, it says in this diagram, triangle DEF is similar to triangle JKL. Identify the pairs of congruent angles. Write a proportion that relates the corresponding sides. So I could say angle D is congruent to angle J. Angle F congruent to angle L. Angle E congruent to angle K. So then it says write a proportion that relates the corresponding sides. So I would have DE over JK. That would equal DF over JL, which would equal EF over KL. I notice that this one, KL, has a radical, as does EF. So let's use one that doesn't have those. Okay? So if I took this very first one to find my ratio, DE is 15 over JK 20. 15 and 20, the biggest number they have in common is 5, so that reduces to 3/4. So the ratio of all the corresponding sides would be 3/4. Okay. All right, example number 2 on the back. Here we don't have a picture, we're just going to look at the statement. The statement of similarity. ABCD is similar to FGHI. Okay, so corresponding angles. Angle A is congruent to angle A, and F are in the same spot. Angle B is congruent to angle G. Angle C congruent to angle H. Angle D congruent to angle I. Corresponding sides. They gave me AB is proportional to FG, BC, so that's the second and third place. So over here, second and third, GH. They gave me HI, so the last two, so that would be CD. FI, the first and the last, AD. We're going to try that again. So number 3, list the congruent or proportional parts for the given statement. So triangle FRO is similar to triangle STY. So corresponding angles. Angle F congruent to angle S. Angle R congruent to angle T. Angle O congruent to angle Y. Segment RO is proportional to segment TY. But it is proportional to SY, so that would be FO. So that's how we do it without a picture. We just use where they're sitting at in the statements. So now we're going to talk about scale factor. Scale factor or similarity ratio, it's the same thing. That is the ratio of the lengths of the corresponding sides of two similar polygons. Okay? So here it says, what is the common ratio or the scale factor of QRST to ABCD? They're all going to be the same if they're similar, so I just need to pick one similar side and work out that proportion statement. Okay? So let's say I wanted to do RS is proportional to BC. So RS is 18, BC is 12. 18 and 12, biggest number they have in common, 6. So that reduces to 3/2. So the common ratio of 3/2 is also the scale factor of QRST to ABCD. Okay? All right. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor of QRST to JKLM. So I see the angle Q is congruent to angle J because they have the same markings. Angle R is congruent to angle K. Angle S congruent to angle L. Angle T congruent to angle M. So the angles are all congruent, corresponding. So now I need to see if the corresponding sides are proportional. So I need to check, is QR over JK equal to RS over KL equal to ST over LM equal to QT over JM. I need to see if all of these have the same ratio. So we'll just start with the first one. QR, so 30 over JK, which is 21. So 30 over 21, biggest number they have in common, 3, so that is 10/7. So I'm looking to see, can I get 10 over 7 for all of the other ones? So RS is 20 over KL, 14. Biggest number they have in common, 2. I get 10 over 7. So now let's do the ST. So ST is 25 over LM, 17.5. Again, I want to get rid of that 0.5, so divide everything by 0.5. So then I end up with 50 over 35. Biggest number they have in common is 5, so I get 10 over 7. The last one we want to do is QT, so QT is 27 over JM, 18.9. I need to get rid of the decimal 0.9, so divide by 0.9, top and bottom. When I do that, I end up with 30 over 21. I've already gotten one of those, I know that's 10 over 7. I got the exact same ratio each time. So yes, I could say QRST is similar to JKLM. The scale factor, I'm going to call that SF. That's the ratio of my sides, was 10 to 7. Okay. Next example. Decide whether or not the figures are similar. If they are, give the scale factor for the two figures. Okay. So again, I see angle G and K are marked the same, H and L, I and M, J and N. So I see my angles are all marked the same. So I want to check my side proportions. So I want to check GH over KL. So that is 6 over 9, which reduces to 2/3. So next one, I'll check HI over LM. So that's 10 over 15. Reduces to, they both have a 5 in common, 2/3. Next, I would check JI over NM. So I would get 2 over 3. And finally, GJ over KN, 4 over 6, which reduces to 2 over 3. So yes, they are similar. So I could say GHIJ similar to KLMN. My scale factor, or the similarity ratio, is 2/3. Okay. All right, the next one, B. Again, they all have 90-degree angles, so I see that those are all going to be the same. So I need to check RU over IL. So RU is 3, IL is 6, so that reduces to 1/2. So then let's check US over AI. That's 5 over 8. They don't have anything in common. 1/2 does not equal 5 over 8. Therefore, not similar. They're not similar, so I don't have a scale factor. Okay. All right, so now it says in the diagram, triangle ABC is similar to triangle DEF. Find the values of X and Y. So if they're similar, I know that I have proportional sides. I know that all of the sides then will have the same scale factor. So this side and this side don't have any variables. So if I look at what is the scale factor, 14 over 42. They both have a 7 in common, so that would go in there 2 over 6, which will reduce to 1/3. So my scale factor is 1/3. Okay, so I know that all of these, so x plus 5 over 60 is going to equal 1 over 3. Now I have a proportion, cross multiply, 3 times x plus 5 equals 60 times 1. Distribute, 3x plus 15 equals 60. Subtract 15. So I get 3x equals 45. Divide by 3, x is equal to 15. So there's the x value. So now the y value, I have y minus 6 over 63 equals, again, the scale factor, 1 over 3. Cross multiply, 3 times y minus 6 equals 63 times 1. 3y minus 18 equals 63. Add 18 to both sides, so I get 3y equals 81. Divide by 3, y equals 27. So we just found x and y. All right, so last page, perimeter of similar polygons theorem. If two polygons are similar, then their perimeters are proportional to the scale factor between them. Okay. So in the diagram, MNOP is similar to DEFG. MN is proportional to DE, which equals 5 to 3. Right? So they're giving me the scale factor is 5 to 3. Find the perimeter of each rectangle. So here, my perimeter of MNOP, okay? The perimeter of DEFG. I need to find out what X and Y are, right? I know that my scale factor is 5:3. So I can set up, I can say MN over DE equals NO over EF. So MN is 20 over DE y minus 3. That has to equal, well, it also equals my scale factor, which they tell me was 5:3, 5/3. Cross multiply, so I get 5 times y minus 3 equals 20 times 3. 5y minus 15 equals 60. Add 15 to both sides, so I get 5y equals 75. Divide y equals 15. So now I'm going to do the same thing with the x plus 4 and the 7.2. So x plus 4 over 7.2 also has to equal my scale factor, 5/3. So when I cross multiply, 3 times x plus 4 equals 5 times 7.2. Distribute 3x plus 12 equals 5 times 7.2 is 36. Subtract 12, 3x equals 24, x equals 8. So here, x equals 8, so this is 8 plus 4, this side is 12. Y was equal to 15, so 15 minus 3 equals 12. So the perimeter here, this is 20, this is 20, this is 12, this is 12. So my perimeter is going to be 20 plus 20 is 40, plus 12 plus 12, so we're 40, 50, 64. So the perimeter of MNOP is 64. They did not give me any kind of units. So over here, then we're going to have 12, 12, 7.2, and 7.2. So 12 plus 12, 24, plus 7.2 plus 7.2, 38.4. There's the perimeter of that one. Okay. All right, so last example. Here they don't give me a picture. It just says two similar figures have a scale factor of 4 to 5. The perimeter of the smaller figure is 16. What is the perimeter of the larger figure? Okay. Remember the theorem at the top that told me if two polygons are similar, their perimeters are proportional to the scale factor. They gave me the scale factor here, 4 to 5. So my scale factor is 4 to 5. That's going to equal the proportion of my perimeter. The perimeter of the smaller figure is 16. Well, 4 is smaller, so 16 goes on top over P for the perimeter is what I'm looking for. So that's how I set up this proportion. Cross multiply, 4P equals 5 times 16. So 4P equals 80. P equals 20. They didn't give me units. The perimeter of the larger figure is 20. All right, so that wraps up section 6.3. Your homework today is worksheet 6.3. Remember, tomorrow we're taking a quiz over 6.1, 6.2, and 6.3, along with the vocabulary bit.